This question asks how many mechanistic arrows are required to bring about the following transformation. So to answer this question, we have to think about what processes are happening, what arrow pushing patterns that we're going to have occur. We also have to take really close stock of what our starting material is, what our intermediate is, what our product is, because we have to think about what's happening in this reaction. So let's go ahead and do that. First off, we have an alcohol right here. And then we have a H- right here, and this is a strong base. Okay, anytime you have H-, it's pretty much going to act completely as a base. So that's important because it identifies what our key reagent is. Two of the key arrow pushing patterns that we've talked about are nucleophilic attack and proton transfer. In order to have nucleophilic attack, you need something that will be able to act as a nucleophile, and this base won't. All right, so that narrows our choices down a little bit. We know that nucleophilic attack probably isn't going to happen. We can also look at the intermediate right here and see that it's lost a proton. So that is also supporting evidence that the first thing that we're going to see is proton transfer. Proton transfer requires two arrows. Arrow number 1 is going to start at the area of electron density on the base, which is a lone pair, and go to the hydrogen that it's abstracting. And then arrow number 2 starts at the bond between the hydrogen and whatever it's attached to, in this case, an oxygen, and then goes to that atom. So that's our second arrow. So we have proton transfer occurring here in step number 1. In step number 2, we have an O-. O- can be a nucleophile or a base. So we kind of have to be careful here, nucleophile or a base, to think about what's happening. In order to really think that through, we need to see what type of a product did we make. Okay, the product has a new carbon to oxygen bond. And so that's significant because it's telling us that we probably had nucleophilic attack occur, because nucleophilic attack makes new bonds. So how would that happen? Okay, nucleophilic attack in its simplest form has only one arrow. We have a good electrophile right here with our nucleophile. And so the arrow that we'll need here is going to start at the nucleophile and then go to this alpha carbon here of the alkyl halide. We're also going to have a second arrow occur right here. So this has two arrows happening at once. This is an example of an SN2 reaction. Right, so an SN2 reaction has simultaneous nucleophilic attack and loss of a leaving group occurring. So these two steps are combined. Okay, so I'll put nucleophilic attack plus loss of a leaving group. Right, and then the product of this reaction is an ether. So this is actually a second semester reaction called the Williamson ether synthesis. We use two arrows to show the nucleophilic attack and the loss of a leaving group. So to get back to the question that's being asked, how many mechanistic arrows are required to bring about the following transformation? The answer to that question is 4. We need 4 arrows, 2 for the proton transfer, 2 for the SN2 attack.